Hi everyone, we're going to find the critical numbers for f, and we're going to find the open interval where f is increasing or decreasing, and apply the first derivative test to identify all relative extremum. And I'm going to first do the first derivative test. I can rewrite this as x to the fifth over 5. This whole thing should be over 5, sorry. Minus 5x over 5, which that cancels out. So when you take the derivative, you're going to get 5x to the fourth over 5 minus 1, and that cancels out. So basically we get x to the fourth minus 1. Now factoring this would be x squared minus 1 times x squared plus 1. And then we can factor this more completely, and this would be x minus 1 times x plus 1. And then we still have this piece. Now there's no real solutions. When we set this to 0 to find our critical numbers, this one has no real solutions. You set this to 0, you can get plus or minus I. And that's not a real number. So we're going to disregard that. So our critical numbers are x equals negative 1 and 1. So we did both of these. And now we're going to find the open intervals. So first of all, our critical numbers for x equals negative 1 to 1. So we're going to test intervals from, and I'm just going to write it like this, negative infinity to 1, and then negative 1 to 1, and then I'm going to test 1 to infinity. And we're going to plug in numbers there. So if I take my derivative, which is f, it's going to be x to the fourth minus 1, and I plug in a number smaller than 1 for this first interval. So if I plug in 0, I'm going to get negative 1. That's a negative number. So for, oh, we can't plug in negative 1. Sorry about that. This should have been negative 1. So let's plug in negative 2. If I plug in negative 2, I'm going to get 16 minus 1, which equals 15. And this is a positive number, so my derivative of f is positive. It's a positive number. Now if I plug in 0, like I did before, if you plug in 0, that's going to equal negative 1. And that's going to be decreasing, or the sign is negative. And if I plug in 2, clearly that's also going to be positive, because you're just raising it to an even power. Therefore, our intervals that are increasing are these two. So these are our increasing intervals. And this one, since this is negative, is my decreasing. And now the only thing I have to, so it's decreasing on this interval, and we got to do relative minimum and maximum. So what I'm going to do is I'm going to plug in my critical numbers into my original function. So my original function was f of x equals x to the fifth minus 5 over x, 5 times x over 5. So we're going to plug in our critical numbers, which should be f of 1. You plug in 1, you're going to get, let's see, negative 4/5. And when you plug in negative 1, you get 4/5. And so I'm going to have let's do negative 1 4/5, and we have 1 comma negative 4/5. Since this is bigger than this number, this is your maximum, and this is your minimum. Okay? Thank you. Have a nice day. Bye-bye.